Hi everyone, this is lesson 5.3 and we're going to be breaking up this lesson into two parts. So there's going to be a 5.3a and then in class I'll teach you the 5.3b. And so this is on linear patterns and models and we're basically setting down the foundation or the building blocks for you to understand what a linear model is and to create equations for it. And so what I mean by a linear model is when you start to graph and compare a relationship between two quantities or two variables, what's going to happen in a linear model is you'll see that it takes the shape of a straight line. In other words, if I were to graph it, the dots are going to be in a straight line. Okay, so we're going to go over some examples. This is example number one, but you will be able to have a little bit of practice for yourself as well, okay, at the very, very end. So example number one, starting off very straightforward, we have these figures or these shapes. We're going to call them frames. So this is frame or shape number one. This is frame number two, frame number three, and frame number four. Now in each of these frames, it's asking us to determine the perimeter for each one. And so when I add up all of the sides, that's going to give us the perimeter. And so see, there's a little one right here representing this as one unit. And so 1, 2, 3, 4, 5, 6. There are 6 sides, and you add them all up and you get a 6. Okay, so the perimeter is 6. Now for the second one, we're just going to try that again. 1, 2, 3, 4, 5, 6, 7, 8. So the perimeter of frame 2 is going to be 8. And again, if you just count up the sides, you're going to get a 10 for this frame and then a 12 for this frame. And that's where I got these numbers from. Now, putting that into a table of values, which is what this is, or a graph, what we're first going to do is understand that we have an independent and dependent variable. This relationship is looking at the frame number, so these guys, the names, and then the perimeter of each of those specific frames. And so depending on the number, you're going to get a certain perimeter. And so this is the independent variable, which means that it's going to go underneath on the x-axis, and this is going to depend on the frame number, and so the perimeter goes on the y-axis. Probably should have put labels here, but I'm explaining it verbally. Okay, so I've copied down these four numbers into this, and this slot, but I didn't have the frame number for the fifth one. I'm pretty sure you see the pattern and you could probably draw it yourself and count up all the sides, but why bother doing that? That's a lot of work. What I noticed instead is that if the first frame number has a perimeter of 6, the second frame has a perimeter of 8, it increased by 2. And if the third one is 10, it also increased by 2. And so following this pattern of increasing by 2, I don't have to draw the fifth frame. I can just count an extra 2. And I know that the fifth one will have a perimeter of 14. Now we could also draw that on a graph where you put, say, this coordinate, the first frame number of a perimeter of 6, first frame number of a perimeter of 6, and then do each of the following dots, and you'll notice that you get a linear, so a straight line relationship. In that if I just continued the line of best fit, which notice that you have an arrow this way, it keeps going this way, not this way because that would be into the negatives, which doesn't make sense in this scenario. But if I continued the line of best fit, it would just follow that straight pattern and I could see that a frame 5 should have a perimeter of 14. So I can show that to you that we can make a prediction about the fifth frame graphically using the line of best fit or through the table of values by just continuing the addition pattern. Now we can answer some questions now that we kind of have the pattern down. What do you notice about the growth of the pattern? Well, it looks like from the graph a very perfect or strong positive, because it's going upwards, correlation. They could ask me to also predict further frames, which is what is the perimeter of the ninth frame. And so I only went up to 5, but I can definitely continue the pattern until I get to 9. So here I have fifth frame, sixth, seventh, eighth, and ninth frame, and then continuing the pattern of adding by 2, and I get to 22. So using my table of values, I could predict that the perimeter will probably be 22 by the time we see the ninth shape. Now this is the part where it's going to get a little bit tricky, and I'm going to do this twice with another example, possibly even 3 times in this video, and hopefully you'll understand it. This is a little bit tricky. Now, we can create a pattern rule. In other words, this right here is a rule that will allow you to predict further numbers based on the independent and dependent variable. Remember that the independent variable is your x, the dependent is your y, and so I'm trying to make some sort of a rule with my x and y. By the way, this right here is also an equation, which is the name of this line. It is the name of the line of best fit. Okay, so it allows you to create the line of best fit, all of the dots that belong on it. Let me show you. So we always start off with the dependent variable y equals, and this is the perimeter. So the perimeter is equal to, take this number that keeps repeating that pattern that we had saw, the adding by 2, and stick it right here. Okay, this is going to be what we call the rate of change. Okay, and that's going to multiply our x value. Our x value is our independent variable, which is our frame number. Now, where did this 4 come in? That's the confusing part. Okay, so I kind of predict what this number should be based on just trial and error. So for example, this is my check over here. I know that when I put the 9 into my x, I should get a perimeter of 22. And we know that by creating this pattern of adding 2 each time. Okay, so then if I don't know what number should be back here, because I'm essentially guessing, this 2 multiplied by the 9 will be an 18. Now I'm going to guess that I'll probably have to add 4 so that my final answer, which is the perimeter, gives me the 22. So this is kind of like a guess in order to complete the original part of the rule. So the part of the rule again is you're always going to take whatever this number is, you're going to multiply it by the independent variable, see 2 times your 9, which gives you 18, and it has to equal to your perimeter, but notice that the perimeter is not 18. And so I forced it to be 22 by adding a plus 4 at the very back. And that's actually kind of interesting, this plus 4 business. This guy is your initial value, which means that if I went backwards and subtracted 2 to get to the original number, see this guy right here, if I subtracted 2 to get to the original number, this is what we call our initial value. That number right there, the plus 4, is actually what goes here at the back of our equation. Let's try this again because I know that that was kind of confusing. We'll start all over. Okay, this is example number 2. So Yasmin made this pattern with tiles. And so she has figure 1, figure 2, figure 3, figure 4, and we put those right here in our table of values. And now we can count up how many tiles we have in each of the figures and record them into our number of tiles column. And so this is our independent variable, which means it goes down at the bottom. Okay, figure number. This is our dependent variable, which means it goes onto the side. Okay, and so notice that, I mean, even if you take a look, your pattern seems to be decreasing in size. And that can be seen as well, that when I go from 9 to the 8, I am decreasing by 1, decreasing by 1, decreasing by 1. And you should see some sort of a decrease in the number of tiles as you go on. Okay, and so how do you know that it's linear? Well, it creates a straight line when you join up all of the dots. Then they're going to ask you questions like predicting. What about the 8th figure? Because you only went up to 4. What's that one going to look like? How many tiles does it have? And what about the 10th? And so instead of drawing the pattern over and over until you get to the 8th or the 10th, you can use the pattern rule. And so you notice that it's subtracting by 1 each time. Why don't we just continue that pattern? So we ended off with 4, see, 4 and 6. And then I'm just going to continue increasing the figure number, but decreasing the number of tiles by 1. So it goes down 1 each time. Now, if they're asking for the the eighth figure has only 2 tiles. And you can kind of see that in the graph. The eighth figure has only 2 tiles. And then the 10th, well, the 10th is where it has no more tiles. And we can see that in our table of values as well. So you should visually see um, in a graph what the table of values algebraically is showing you numerically. Okay, now again, that hard part is the pattern rule. This is the name of the line of best fit. It shows you the pattern of how to find the dots that make up the line of best fit. So what you're going to do is take this -1 number. That is our rate of change. It always goes right beside the independent variable and they're going to multiply each other. In this case, that's the number of tiles. Okay. And then what you're going to do, oh, I think I mixed this up a little bit. I apologize. Sorry. This should have been the figure number. My mistake. Please change that on your own notes. This should be the number of tiles. This is your dependent variable. So you always start off with your y. Y equals -1, your rate of change, times your figure number, your independent variable. Okay. Now I have no idea what number this should be, unless of course I graph it and I look at the initial value. So that's a 10. That's how I know that this would be a 10. Another way that I would know is using the table of values. I'm going to just do an algebraic check. So I'm going to substitute 10. You just pick one of the groups. So substitute, actually, no, I did the 8 over here. So substitute the 8 into your x. So -1 times 8 gives you -8. But the answer should be 2. And so I have to add a 10 at the back in order to get my answer of 2. Okay, so there's 2 different ways algebraically or visually that you can find the 10. Now this very last question over here is a third example, pretty much the exact same thing. We're using different tiles and different term numbers, which is your independent, and the number of tiles will be your dependent. And so it's the exact same thing. I'm noticing that it's increasing by 3 each time. I can graph it and I can create so they're asking us which one of these is actually the pattern rule. So remember that this red number, the +3, is the rate of change that will go beside the independent variable. In this case, it's n, which is the term number. See, term number, the independent variable. So the 3 is what gives away that it's probably going to be either B or D as the correct answer for the pattern rule. A and C are incorrect because they have a 5 there instead. Okay, but notice that B and D have a different number at the back. That's the initial value. So taking a look at my graph, the initial value should be 2. Okay, so this one is incorrect. The last one should be correct. Or we can use the table of values to do a quick check with a group of answers. And so if I use the pattern rule, we're going to take the 3 times the term number, which is 5, see right here, and you're going to get 15. But the answer for the number of tiles should be 17. If you just multiply 3 and 15, you're going to get, 3 and 5, you're going to get a 15, not a 17. So you have to put a +2 into your pattern rule. That's how I know that this is the right answer and this is the incorrect answer. Okay, so that's pretty much the video. You can try yourself by creating your own pattern. All right. And just creating your own question essentially. And then the last page is your homework. Okay, so I'm just going to scroll down slowly just so that anybody else who is not in my class wants to follow along. You're more than welcome to pause the video and do that. Have a great day, guys.